I'm going to cover two lessons today. I'm going to cover 11.2 on scatter plots and 11.3. It is up to you how you want to do this. If you want to watch the whole video today and then do the assignment from 11.2, that's great. You'll be all set to cover 11.3 tomorrow. If you want to watch just up till I finish discussing 11.2 and do your homework and then resume the video tomorrow, that's just fine. The explanation for 11.2 is a little shorter. So that's why I'm going to just go ahead and knock out one video, but it'll cover both Tuesday and Wednesday's homework assignment. If you don't have it already, go ahead and grab your book so we can look at this together. We are doing 11.2 and that's on page 588. Okay, and I wrote up here we've got 11.2 and 11.3. All right, we're going to talk about scatter plots today, and you can imagine that scatter plots look like their definition, kind of a scattered assortment of data. We've done line graphs this year, and you know what those look like, and you've practiced graphing and things like that. These are going to look a little different. So if you're on page 588, I'm just going to go through the examples a little bit and talk about it, but you can see the definition. In the middle of 588, a scatter plot, it's a graph of a collection of ordered pairs. Okay, again, we're plotting points. That's how you know that. And sometimes these numbers are really large, so keep in mind when you do a graph, you don't have to always start with 1 and make every square, every line worth 1. If you look on example 1, they're graphing some data, and it goes up to almost 1,000, so they make every line worth 200, and then the next 400. What you have to be sure of is that your increments are consistent. You can't go by 200, then 100, then 300. You have to keep your increments consistent. So there you see the distance along the bottom is by 1, and on the left side, the fuel used is by 200s. Okay? We're going to look at page 588. It's really just the graphing, and I'm going to remind you of what that looks like. All right, when you graph a scatter plot, let's look at the guided practice. I'm going to go ahead and change colors here just for fun, keep it exciting for you. The guided practice on page 588. All right, and what I'm going to do is I'm just going to go ahead and do this graph and put these points here. You should recognize that the top is usually your input, which we talked about in yesterday's assignment. Your top is input or your x value or your domain. All right, so in this case, the first coordinate I would look at, it's a table there, but you should recognize that first one would look like a coordinate like that. -1, -4, 0, -3, and 1, -2. Now in this case, these look like they're going to be pretty even lines. Your data won't always be. So -2, -5, I've got a point there, -1, -4, 0, -3, 1, -2. Okay, so in this case, those go up pretty steadily. I'm going to look at the other ones. Let's do that in blue. 0, -2. And hopefully you can all see this on the guided practice. 3, -4, 6, -6. Okay, and the last one, 9, -8. This is a good one because it's a little more random, okay? So I'm at 0, -2. There's that one. 3, -4. All right. 6, -6. So we're at 6, which means I go right 6 and down 6. That you hopefully remember. And then 7, 8, 9, -8. Okay, so you can see this here is going this way. And this graph, in this case, these were both lines. And this one is going up this way. If you look on the top of page 589, you'll notice what do we consider when we look at this kind of a graph and we're trying to make conclusions about some data we're given. If you look on the top of page 589, they talk about relationship. Okay, what is the relationship? So if I'm looking at this red line, you can see that is going up, right? We would say that's a positive relationship. We give it a thumbs up. Yes, that is going up. That is good. So how would we make that connection? Let's say we were graphing information and it was, how about, here we can understand this. The amount of coffee consumed throughout the day by Miss Winfrey, right? So that would look like a red graph for me. That would look like that red line. As the day goes on, the more coffee I've had, right? So that goes up. It's a positive. As one increases, the other increases. All right? This one's a negative correlation, meaning as something progresses, it is going down. And you can see, or a negative relationship. You're going to use the word correlation eventually in your math classes. They use relationship right now. So as time goes on, so here's been a good thing, right? As this coronavirus has gone on, gas prices have gone down. So here, this has had a negative relationship. It doesn't mean a bad thing. It just means that it's gone in a decreasing manner. Gas prices have dropped as time has gone on. If you look on the top of page 589, you will see the one where there's no relationship. There might be a random set of data. Let's say we were graphing the data of heights of all the 7th graders. Well, that could be all different. You know, you'd have your ages, which are going to be different. Everybody's height's going to be different. There's really going to be no correlation necessarily in that data. So, relationship your book uses. So, you can see at the top of that page, that's kind of what you're doing when you're interpreting data. You're looking at it and saying, what's happening with these numbers? On example 2, on page 589, okay, they have a table there. It's talking about the cost per ounce of breakfast cereal, all right? So when you look at that, they gave you the table of information. You can graph that. You see they made a nice little graph, called it the unit cost on the right side of that example. As they increased the ounces, let's see if I say this right. As the ounces increased, yes, the price decreases. What they're saying is a concept like your Sam's or your Costco, right? When you buy more or buy in bulk, the price overall per ounce goes down. So that's what that table shows you. It shows that the bigger the box you buy, the smaller the price you pay per ounce, per size, okay? On the bottom of page 589, you'll look at that. You could graph those and see what kind of relationship it is. What you need to remember, X is always first, your over up, and your Y is your second coordinate in your data. Okay, I think that's pretty familiar for most of you. So when you go to do your homework on page 590, that's where your homework is today. Again, making sure you're graphing properly. If you have a negative number on the x-axis, it's over here. A negative number on the y-axis, it's down here. For example, -1, -4 was left 1, down 4, right? Over here, 3, -4 was over 3, down 4. So just make sure you pay attention to those signs when you're graphing. On page 590, if you just look at, let's say, number 6, it says, tell whether they have a positive relationship, negative, or no. Well, look at number 6. It's not a straight line, as lots of scatter plots are not. These happen to be, but usually scatter plots are not. You can see the relationship on 6, positive, makes sense. Look at number 12. Here's where it wants you to predict the type of relationship and explain it. Number 12 says the size of a pizza and the price of a pizza. So think about that, and then I'll help you understand what I want you to write. If you think about that, the size of a pizza, as a pizza gets bigger, so does the price, right? I'm going to pay more for a large pizza than I am for a small. So as the size increases, so does the price. It's going to look a lot like my coffee consumption. As the day goes on, so does my coffee consumption. That will have a positive relationship. So for an answer for number 12, you would write, as the pizza increases, the price increases. That's a positive relationship. That explains about everything you need to know for 11.2. Here's where, if you want to go ahead and pause it, you may pause it, pick it back up again tomorrow. Now I'm going to jump into 11.3, but you're prepared for Tuesday's homework with everything we've discussed so far. I'm going to grab this cloth, and we're going to start with 11.3 here. 11.3 is equations into variables. I think this is somewhat familiar for most of you. I'll drink some coffee so you feel like we're right in class together. Which I really miss, by the way. Equations into variables. On page 593, what we're talking about in this is how to determine, if I have two variables, what are solutions for my equation. I'm going to jump right to page 594 instead, okay? You know that solutions, if I'm looking for a solution, what I'm asking for is what numbers, or in this case, what set of numbers, are going to make this equation true, okay? What numbers are going to fit or work. I'm going to jump and look at example 2. They show you some examples there. You are smart students. I'm going to go ahead and let you look through those examples on your own, but I'm going to do some guided practice with you. On this, let's look at guided practice, page 594. So you can understand when it asks you questions, what is it asking you for? So, page 594, guided practice number 2. At the bottom of the page it says, tell whether the ordered pair is a solution of the equation. Ordered pair, you know, looks like this, a coordinate. Is it a solution for y equals 3x minus 7? Does it work? All right, you should remember this is x, this is y. If I plug them in, is it true? So 5 equals 3 times 6 minus 7. Always remember, you don't just put a 6 here making that 36. The 3x means you multiply. So 5 equals 18 minus 7. 6 times 3 is 18. 18 minus 7 is 11. Is that true? Well, no, that's not true. So we use that not equal sign there and say no, it's not a solution. What about number 3? Does it work? Let's see, negative 2x minus 4y equals 12, and my coordinates, negative 4, negative 1. Make sure I wrote that properly, negative 4, negative 1, okay? So here I have negative 2 times negative 4, again watching your signs, times negative 1 equals 12. You'll notice here it was y equals something. Here you had both variables on the same side and a constant on the other. It's okay, you'll be able to figure it out regardless of where that equal sign is. Negative 2 times negative 4, my smart pre-algebra students are going, oh, that's 8, okay? And then I have negative 4 times negative 1, okay? So if I look at that, negative 4 times negative 1, or if I do minus 4 times negative 1, negative 4, equals 12. If you look at it that way, you know that your minus minus is plus. 12 does equal 12. So yes, this coordinate, this ordered pair, is a solution for that equation. What does that mean as far as graphing? Think about it. That means that if I graphed this line, that number would fit on that line. It would be on that equation, the line of that equation. That is what we're doing in the first part of section 11.3, determining whether an ordered pair is a solution. So you need to show your work like I did. If your math teacher has to write out a problem and show work, so do you. So write that out and then write the answer yes or no. Don't just put yes or no. On example 3, finding solutions. All right, so here they're asking you to determine some solutions of these equations. I'm going to have us use some standard numbers, so hopefully you're paying attention to this video. I also did write the directions, I believe, on homework, telling you which ones to use, because you could find a lot, right? Let's just go ahead and look at number 4, y equals, this is guided practice, number 4, let's see, page 594. Number 4. All right, y equals negative 2x plus 6. I want you to learn a strategy today that's going to help you throughout what we're doing later. So we're going to make a table. Now, I like to make my table with x here, y here, and in this portion here, I write what you learned yesterday is your function rule. We're talking about equations today. All right, and so for number 4, it says list 4 solutions of the equation. What I want you to do is be consistent in the numbers we're finding. So for x, we're going to use negative 2, negative 1, 0, and 1. Could we use 3 billion, negative 27? Yes, we could use all sorts of solutions and figure out those answers. I want us to be consistent. I want us to be able to track it when we have to graph it. So in that case, it's best to use some negatives. You use a 0 and positive, and you'll get a good sense of what that graph looks like. So what do? I'm going to plug negative 2 into my equation. Now, right now, I'm going to be very thorough in my work. So negative 2 times negative 2 plus 6 is 10. What I do at the end of that is write, okay, so my ordered pair, my solution is negative 2, 10. That is one ordered pair that works in that equation. What's another one? Negative 2 times negative 1 is 2 plus 6, 8. So again, I write it as an ordered pair, my x and my y. What about when I put 0 in there? And I have my ordered pair. And then I substitute 1. Negative 2 times 1 plus 6. Negative 2 plus 6 is 4. So my ordered pair there is 1, 4. They're not asking you to graph it. They're just asking you to find 4 solutions. All of our x's should be the same. Negative 2, negative 1, 0, and 1. Then if you did it right, these are going to be the outputs, 10, 8, 6, and 4. Okay, and you write those in a nice, neat, ordered pair on your homework. Let's do number 5 and make sure we have this down. Again, I do want you to use those same 4 solutions. Same 4 values for your input x. So 5, my equation in this case says 3x plus y equals 4. Now, this is very important. You can use your table and do what I did before with it just the way it is, but it is a little bit more complicated to find y when you have to put it in this way. So my suggestion is to get your equations when you're solving them and putting x in to be y equals format. You have to have your y as positive. So I'm going to leave my y and I'm going to move my 3x to this side. So my new equation is going to say y equals negative 3x plus 4. Now it's easy for me to solve. It's the same, right? We just rearranged it. But now it's easy to find out y when I plug in x. So I'm going to do this. Again, we're going to use negative 2, negative 1, 0, and 1. Negative 3 times negative 2 is 6 plus 4. That's 10. So here we are. Negative 2, 10. Okay? And then I'm going to plug in negative 1. Negative 3 times negative 1. Negative negative is positive. I'm going to get 7. There we go. 0. Great. I get 0, 4 for my next coordinate. And negative 3 times 1 plus 4. Negative 3 times 1 is negative 3 plus 4 is 1. So my last ordered pair there is 1, 1. Again, when you're doing your homework and it says give 4 solutions, please use negative 2, negative 1, 0, and 1 for your input, for your x values. You should be good to go. This covers everything you'll need to know for Wednesday's assignment. Thursday, I think we're doing review, but you know, I've only had a minimum amount of coffee, so don't quote me on that. Hope you're having a great day. If you need help, again, Google Meet, Mondays and Wednesdays, 1 to 2. Have a great day.